All right, I'm going to do a second example now as well of a different line, and I'm also going to do it without a grid just to show you how you can sketch a line when there's no grid or set of axes already available to you. So the line that I'm sketching is the one here, y equals negative 2x plus 20. So like we said before, we need 2 points in order to do that. And our first point is given to us for free in the fact that the y-intercept is c equals 20. So that means there's a point on our line where x is equal to 0 and y is equal to 20. So there's our first point already done. Now, we just need a second point, and we can generate that by choosing any x value we want and substituting it in. So I'm going to try x equals 5. And the reason why I write at x equals 5 is because I'm really saying at x equals 5, so when x is 5, what will y equal? And let's find out. Y is equal to negative 2. Now x is replaced with 5 plus 20. So negative 2 times 5 is negative 10 plus 20. Negative 10 plus 20 is positive 10. So now I've got an x value of 5 and a y value of 10. So therefore the point 5, comma 10 exists on our line. So now we've got both points. Let's just think about them and think about what sort of scale we need for our axes. So the highest x value we have is 5, so we don't need to worry too much about the x values. But the highest y value we need to have is 20. So we just need to think about that when we start labeling the scale of our axes. So let's draw these axes up now. Remember, this is just a sketch, so we don't need to be perfect, but we want to do the best we can to make sure that we're drawing some straight lines that are at right angles to each other here for our axes. And I know they're a little bit bumpy, but that's okay. That's like a Bob Ross painting in a way. Now I'll label my axes. That's my x-axis, that's my y-axis. Now let's start putting some scale on these axes. So my x-axis only has to go up to 5, so that'll be quite easy. I need to make sure each of these is equally spaced apart, because what's worth 1 over here has to be worth 1 over here as well. The distance of 1 has to be the same. And there's 5 at the end. Now they're roughly the same distance apart. I'm doing the best that I can, and that's all you need to do when you sketch. You do the best that you can. Now my y-axis, I've got the same distance, but it has to go up to 20. So I'm going to go up in jumps of 5, because then I only need 4 jumps to get there. So here's 5, and I need to replicate that same distance for 10. Now that same distance has to represent another jump of 5, so that's 15. And then my same distance represents the last jump of 5 to get me to 20. So my x-axis and my y-axis, both of my points exist only in the positive part. So I don't really need to worry about labeling these negative parts right now. But if I did, I'd need to keep the same scale. So I'll just demonstrate that really quickly for you. So I'm keeping the same scale, but this is negative 1, negative 2, negative 3, and negative 4. This is negative 5, negative 10, negative 15, and negative 20. Alrighty, let's mark these points in so we can join them up. So my first point was 0, 20, so that's x is equal to 0, y is equal to 20. There's the point right there. Now my second point is 5, 10. So when x is equal to 5, y is equal to 10. So there's a point there. So now that I know sort of where my line will be, because it has to join those, I can label these points without my label being in the way of the line, because the line is going to be in between these points. So I can label now without crossing over where that will be. So here's 0, 20, this point, and this point was 5, 10. So let's join those 2 points together now with as straight of a line as we can. And then that line needs to continue on past those points as well with the same exact gradient, because it's a sketch as close to the same as we can. There we go. So it only exists in that quadrant and a little bit in the quadrant to the left of it as well. Now that I've labeled my points, I've labeled my axes, I've drawn my line, all I need to do now is label my line as well. So the line was y equals negative 2x plus 20. And there we go, that question's complete as well. Before we finish this video though, I'll just remind you of the details that you need to make sure you mark in on your graphs. Especially in exam situations, you'll lose marks if you forget to do any of these things. So the first thing is you have to label your axes. So you can just label them X and Y if it's not a real life situation, but they need proper titles if it's relevant. So for example, maybe my X-axis is time and my y-axis is cost. I need to label those things if they're relevant. And I also need to label the values, so the scale of the x and y axis. Now, the second thing we need to do is we need to label our points with an x value and a y value in brackets, so x comma y, like we've been doing in our previous two examples. The third thing is we label the line itself with its equation, just like I did in the previous example and the example before. And then this fourth one is sort of optional. It's not completely necessary. As long as your line goes all the way to the edges of the axes, you've done the right thing. But it's sometimes convention to also put arrows on either end of the line, like I did, to show that the line continues past the axes. So like I did in this one here, I put these arrows on to show that the line actually continues off infinitely. But those are the four things you need to remember to label onto these graphs to get full marks. Thank you, Year 11. This has been Mr. Gallagher. I hope this video was helpful. Have a great day and good luck.